All right, welcome back. Well, of course, it's Dr. Pitcher again, and in this lecture, we're going to be looking at oxidative cleavage of alkenes. Now, what is oxidative cleavage? Well, it involves breaking the CC double bond with oxidation going on at the same time. So we saw an oxidation in adding H2O2, so adding OH to both ends of the double bond. But what if we took something like this, and treated this with KMNO4 hot and OH minus, so hot basic KMNO4. What we'll end up getting is two molecules of acetone in this case. So whoops, what's happening is we form that same permanganate, cyclic permanganate intermediate, but it keeps on reacting, and we get cleavage of this, that double bond there. Now there's some interesting features to this reaction, and that is that if we have, let's say we have, let's do the following. Let's do this double bond. So we'll do this alkene, and we'll use KMNO4, hot and basic. We will get so I have a hydrogen there, and with permanganate, when I cleave that, I actually end up oxidizing at the hydrogen as well, and I get a carboxylic acid. Now, there are some other methods of cleaving alkenes, oxidative cleavage, that maybe won't stop at the carboxylic acid. And one of those is ozonolysis. So when you have your own little portable ozone generator, you can do the following. A lot of times, I'm going to say DMS here, just dimethyl sulfide, or zinc, and it's like aqueous acetic acid. And now what we end up getting is the aldehyde, and in this case, the ketone. Okay, so when we do ozonolysis, we'll go ahead and break that carbon-carbon double bond. We'll insert oxygens on both ends, so we'll make new CO double bonds. But we don't go all the way to the carboxylic acid. We actually stop at the aldehyde. And this forms, ozonolysis also involves the formation of a cyclic intermediate. Let me just hold on here. Let me think for a minute here while I do this here. Let's do it this way. Do that, 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 that. O, 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 and then I've got a methyl going down, and over here I've got the hydrogen going down there. So this is called a melasonide, which then rearranges to make, let's see if I can do this here. This ozonide. And now this then is treated with DMS to get the products. And it would help if I actually put this in frame. There we go. So again, this mechanism I'm not going to hold you responsible for, but I want you to understand what's going on and see the similarities. You know, you're doing the syn addition like we did with the hydroxylation with permanganate or with osmium tetroxide, adding the two oxygens, the same face of our carbon-carbon double bond. Then we get this rearrangement, and then this will cleave, this will fall apart and give us our two carbonyl species. Now there's one more that I want to mention, and that is if you have a diol to start with, so if you had a diol to start with, so let's say we had the following here, OH, OH, boom, boom. You could treat this with, come on, Wayne. Let's try this again here. HiO4. So you can use periodate or periodic acid, and typically this will be with water and THF. That's just a solvent, tetrahydrofuran, and it will form a cyclic periodate intermediate, which then ends up being cleaved into the aldehyde and the ketone. So again, we'll get the aldehyde here. Notice, however, that you have to start with this species. Okay, so you know you could make your diol by maybe by an epoxidation and ring opening. You could make it by osmium tetroxide, and then, or maybe you've created it another way. Or maybe you were given a bottle of this particular diol, and you wanted to make an aldehyde and a ketone from it. Anyway, you wouldn't be starting from the alkene, but rather from the diol, and you still could get that cleavage there. So those are some different ways of doing oxidative cleavage of alkenes. And notice, you know, in all these cases, we are, of course, breaking bonds, and we're adding oxygen. Here, well, I haven't added any oxygens, but I've increased the number of carbon-oxygen bonds. So here I've got one carbon-oxygen bond, one carbon-oxygen bond. Now I've got a double bond, so that counts as two, and that counts as two. And in these other cases, of course, I've added oxygens. So that's oxidative cleavage. And that wraps up the bulk of the actual reactions for this chapter. And I'm going to be skipping some of the sections, so I won't go into sections 8.9, which is addition of carbines, 8.10, which is chain growth polymers, radical reactions, 8.11 I won't go into, which is biological additions of radicals to alkenes. I think I'll try to record another video for 8.12 and 8.13, just talking a little bit about stereochemistry. But really what I wanted these videos to do is show you the variety of addition reactions and cleavage reactions of alkenes, as well as some of the important mechanisms. I've tried to highlight those, and when we meet in person, I'll go over again which mechanisms are important and which ones you will need to know for a quiz or exams. All right. Well, until then, stay safe out there. Bye now.